The collision of two neutron stars near Earth could lead to the destruction of atmospheric layers and the extinction of life on our planet, but how likely is this event? The collision of two neutron stars orbiting each other in a decaying orbit is an extremely rare event. Scientists believe that out of the 100 billion stars in the galaxy, only the fate of 10 neutron stars will result in a collision. So far, a number of explosions known as kilonovae have been discovered, which were the result of neutron star collisions, and none of them are located in the Milky Way. But what would happen if a kilonova were to occur in the Milky Way? Could this event end life on Earth? According to a research group led by Haley Perkins, a physicist at the University of Illinois, if an explosion of two neutron stars occurs close to us, it would have catastrophic consequences for Earth. Findings published on the preprint server AR14 suggest that if we are located more than 35 light-years away from the gamma-ray explosion caused by a kilonova, we would primarily face threats from cosmic rays. However, if we are in the path of such a deadly event, we could even feel its impact from as far as 300 light-years away. By providing estimates, scientists can assess the potential threats of the kilonova event for Earth and also estimate the likelihood of survival in extraterrestrial worlds close to this event. The collision of binary neutron stars, based on observed examples, has several different phases. Typically, during this event, a brief burst of gamma rays occurs. Supernovae from single stars generally last longer. This explosion can create a pair of narrow jets and also gamma-ray bubbles on either side of the jets. When the jets collide with the surrounding interstellar space, they produce powerful X-rays known as afterglow radiation. As the event evolves over years and centuries, a bubble of cosmic rays expands from the center of the collision into space. Researchers, based on their observations of the neutron star merger G170817, have studied the impact of this event on planets. According to their findings, all living organisms within 91 parsecs, 297 light-years, of the jets would likely become scorched due to powerful gamma rays. However, the space outside this narrow jet is somewhat safer. Thus, if you were within 13 light-years of the collision, you would be hit by the gamma-ray bubble structures. Although the gamma-ray emission occurs quickly, it can destroy the Earth's stratospheric ozone, which would take at least 4 years to recover. Meanwhile, X-rays are more lethal because their afterglow lasts longer than gamma-ray emission. However, for these rays to impact Earth, we would need to be relatively close, at about 16 light-years away. The long-term bubble of cosmic rays is considered the most significant threat. These rays, accelerated by the remnants of the kilonova, would make Earth vulnerable to cosmic rays and radiation for thousands of years by depleting the ozone layer. One consequence of such an event could be mass extinction, which would require us to be at least 35 light-years from the source. Therefore, it may be said that for now, we are safe from the deadly consequences of neutron star explosions. In fact, the greatest threat we currently face comes from our own sun's flares. Despite the potential dangers, kilonova events do not rank high on the list of threats. The rarity of neutron star mergers combined with the small range of risk means that these events are not considered significant threats to life on Earth. Additionally, the return time for deadly mergers near the Sun is much longer than the age of the universe. A neutron star is born when the nuclear fuel of a massive star runs out, causing gravity to collapse the core inward. The incredible force of the star's mass compresses the core to very high densities, causing electrons and protons to fussy and convert them into neutrons. While the rest of the star ends its life as a supernova, the neutron star, a dense remnant of the most compact materials in the universe, continues to exist largely untouched. Heavier neutron stars eventually undergo collapse and become black holes. However, a kilonova event nearby, even if it does not lead to mass extinction, would be easily observable from Earth. The stars will likely disrupt terrestrial technologies upon merging and shine in the night sky for over a month.